Welcome back. In this session we are going to learn how to write context-sensitive grammars with NooJ. So as a reminder, context-sensitive grammars are equivalent to type 1 generative grammars in Chomsky-Schutzenberger's hierarchy. Context-sensitive grammars could be more powerful than regular and context-free grammars. They can recognize any context-sensitive language. They are very well adapted to describe constraints between, let's say, verbs and their arguments, such as a verb needs to have a human subject or a concrete object, and agreement, such as an agreement between a determiner and a noun. And they can be processed by linear bounded automata. A very famous formalism to write context-sensitive grammars is lexical functional grammars, LFG, and they are equivalent to context-sensitive grammars. So in NooJ, in order to write a context-sensitive grammars, it's basically the same as a context-free grammar, in which we would add variables and constraints. So context-sensitive grammars in NooJ have two components. One is a description of sequences, thanks to a context-free grammar, and then we add a description for the constraints. From a theoretical point of view, one famous language that cannot be described with context-free grammars, but can be recognized, can be described with the context-sensitive grammars, is a set of all the words that contain a number of A, followed by the same number of B, followed by the same number of C's. So in NooJ, how we write this grammar? Well, we would start by writing a grammar that recognizes any number of A, followed by any number of B, followed by any number of C, and then, when these words are recognized, we would make sure that the length of B, which here has been stored in variable B, is the same as the length of A, which is here stored in variable A, and the same with C. The length of this sequence is equal to the length of this sequence. So as you can see, NooJ recognizes a context-sensitive language by using a purely context-free grammar associated with variables. Here, there is a variable here to store the sequence of A, another variable for B's, and another variable for the sequence of C's, and then we use constraints to enforce the fact that all these sequences have the same length. And if we look at the contract, you can see that this grammar will recognize A, B, 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 C, 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 but will not recognize A, B, B, C, 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 just because the length of B is not equal to the length of A. Another famous language that cannot be recognized by context-free grammars, but can be recognized by context-sensitive grammars, is a grammar that would recognize words that are constituted by a number of A, which is a power of 2. So for example, 2 A's, 4 A's, 8 A's, 16 A's, but not 12 A's or 11 A's. So this grammar is very easy to write in NooJ. This grammar, for example, will recognize AA, and also AA followed by AA, but you see here, we want the length of X to be equal to the length of Y. And this, of course, will recognize any number of A's with the constraint that the resulting sequence has a length which is a power of 2. So for example, 12 is not a power of 2, so AAAA is not recognized, but 16 is a power of 2, so this word will be recognized. A more interesting language, a more interesting grammar for linguists is a grammar that recognizes reduplications. So there are a number of reduplications in many languages. So for example, in English you can say bye-bye, in French you can say papa, bébé, chouchou. So this grammar will recognize any number of word forms followed by any number of word forms. And then the constraints make sure that this sequence of word forms has been repeated, has been reduplicated here. So this grammar recognizes bye-bye, for example. There are many cases where even though we could describe a certain phenomenon with context-free grammars or even regular grammars, it's better to describe them with context-sensitive grammars. So here is an example of a description of French noun phrases. So in French, determiners, adjectives, and nouns have to agree both in gender and in number. So if we wanted to describe the agreement in number and in gender in noun phrases, we would write a grammar such as here. So we are looking for a determiner in the masculine singular, followed by an optional adjective masculine singular, followed by a noun in masculine singular, followed by an optional adjective in masculine singular. But we have to do the same for feminine singular, masculine plural, and feminine plural noun phrases. So basically what we have done here is to duplicate 4 times the same description, which is really not natural, it's not elegant. And it's even worse than that for some languages, such as, for example, for Slavic languages, where we could have 30 quasi-identical path grammars that we would have to be duplicated if we have, let's say, 2 numbers, 3 genders, and 5 cases. So this is not practical. We don't want to duplicate parts of the grammars 30 times. So the equivalent context-sensitive grammar would be very simple. So we would first write a description, a structural description of the noun phrase. For example, I just want a determiner, followed by an optional adjective, followed by a noun, followed by an optional adjective. And then we would just write some constraints, such as the current word, for example, the determiner, has to agree in gender with the gender of the noun. And the same thing, the current word, for example, the determiner, has to agree in number with the number of the noun. So here is NooJ grammar, so NooJ context-sensitive grammar. So this grammar recognizes a determiner, followed by an optional adjective, followed by a noun, followed by an optional adjective. Now we store the noun in variable $n, and then we use a special variable this to refer to the current word. So this here corresponds to the determiner. This here is a variable that refers to the current adjective, and here to this current adjective. So this $nb refers to the number of the determiner, and it has to be equal to the number of the noun, which is here. And the same with the gender. The gender of the determiner has to be equal to the gender of the noun. And we use the same constraints for the adjectives to the left and to the right of the noun. Here is an example of the context-sensitive grammar used in morphology. So this grammar is used to recognize word forms. So this grammar, for example, would recognize any word form that starts with re, di, or des, followed by any number of letters. But then there is a constraint that says, okay, if I find a word form that starts with this, followed by any number of letters, this sequence of letters, I'm going to put them in, I'm going to store them in a variable, that I call verb, and I am going to check the constraint. Is this sequence of letters a verb? So if so, yes, it will be recognized. If not, it will not be recognized. So for example, another example, this grammar would recognize redo, because it starts with re, followed by do, which is a sequence of letters, and then NooJ will check this constraint that says, is do a verb? Do is a verb, so redo will be recognized. However, if the word form to be analyzed is rent, for example, so it will recognize RE followed by NT. NT is a sequence of letters, but when NooJ tries the constraint, is NT a verb? No, NT is not a verb, so this grammar will not recognize rent as a verb with prefix re. We have we already saw two types of constraints. So the operator equals tests that the two sides are identical. So for example, $x, $y, as we saw for reduplication, tests that the value of variable x is exactly identical as the value of variable y. And we can use it also with properties, such as we want to make sure that the number of the variable n is equal to plural, or the number of the determiner is equal to the number of the noun. So this is the equality operator. And we just saw with the morphological grammar that we have also another type of operator, the matching operator. So for example, $x equals colon n tests that x is a noun. So this corresponds to the matching symbol in NooJ. $y equals colon have makes sure that $y is a form, inflected form or derived form of have, of the lexical entry have. And of course, any lexical or syntactic symbol that can be used in NooJ can be at the right side of this operator. There is another third operator that can be used in constraint, which is the existence of a variable. So if, for example, $n here tests that variable $ne has a non-empty value. So the corresponding atomic linguistic unit occurs in the matching sequence. So this is very useful. For example, in French, you are not supposed to have a negation if you don't have the particle ne. So for example, you could write a very simple grammar that recognizes both affirmative and negative sequences, and then you would only recognize the adverb pas, or jamais, never, or plus, not anymore, only if the word ne is present before the verb. In Spanish, you could write the same grammar for affirmative and interrogative sentences, and at the end you only you only recognize the question mark only if the variable corresponding to the opening question mark has a value. So only sentences that start with the opening question mark will recognize the ending question mark. Okay, so congratulations. Now you know how to write context-sensitive grammars with NooJ, and you will be able to use them not only to describe phrase structures, but also agreements, for example, distributional constraints between a verb and its arguments, agreement constraints between a noun and the adjective, or a noun and a determiner.